Okay, so this video is on naive Bayes classifier in artificial intelligence. So let's say I have a data set, or basically a set of documents, and there are two categories here. So like sports and informatics. So this is the main feature that I'm going to use to predict the model, and these are all the features that I'm going to use to predict whether the document is a sports document or if it's an informatics document. So basically these are like goal yes, goal no, speed, defense stats, performance stats, and this is the category. Now, how do I calculate a classifier? So basically, like if you're gonna calculate a classifier, so let's say that I have to calculate the probability of sports given that the goal is no, the speed is yes, the defense is no, so D equals no, and performance is yes. Okay, and you have to use Laplacian smoothing. So I'm gonna get into this, how you can use this. Okay, so first of all, probability of S, G, S, D, and P. So yeah, sports, goal, speed, defense, performance, divided by probability of G, S, D, and P. So the features and the category. Okay, so now first of all, I'm gonna find the above one, this one here. So probability of sports, goal equals N, S equals yes, D equals N, and P equals Y. Okay, so first off, you're going to find goal equals no for all the sports ones. So like sports, no. Okay, sports, yes. Sports, yes. Sports, no. Okay, so this is 1. So 1 out of, so there are 1, 2, and 3. 3 sports here, so 1 out of 3 times the sports speed equals yes. So yes, informatics, yes, sports. So that's 1. Okay, so times 1 by 3. So the number of sports categories times defense equals no. So no, no, no. Okay, so you have 2 no's here with sports categories. So this is 2 by 3 times performance equals yes. So performance, yes, informatics, yes, sports. So 1 by 3 times the probability of sports out of the categories. So there are a total of 5 rows here, and there are 3 sports rows. So this will be 3 by 5. And simply now you're just gonna simply multiply this and calculate it. So the answer should be like 0.0148. Okay, so this is for the sports one. Now you have the top portion, I need this one. So basically this one's like the sports one plus the informatics one. So you're just gonna do the same thing here, except you're going to use informatics. So probability of informatics with goal equals N, S equals Y, D equals N, P equals Y. Okay, so goal equals no, and that is informatics. So no informatics, so that's 2. So this is like 2 out of 2. So 2 by 2 times speed equals Y. So speed equals Y. Informatics, Y yes, informatics. So again, 2 by 2 times defense equals no. So defense equals no 1. So this is 1 by 2 half, and performance is yes. So performance yes is 1. Okay, so 1 by 2. Okay, 1 by 2 times the number of informatics rows. So there are 2 rows out of 5. So this will be 2 by 5. So this should be 0.1. Now, as you can tell, like the probability of it being sports is very low, whereas the probability of the document being informatics is obviously high. Okay, so for this equation, the document is gonna be like informatics because this has a higher probability. But like, let's say I wanted to like put the equation here. So if I had to use this thing, so if it was a sports document, the probability would have been sports. So 0.0148, 0.0148 divided by these two, the addition of these two. So 0.0148 plus 0.1. So the probability should be like 0.0146. So this is for the sports. If it was for informatics, it would have been like 1 minus 0.0146, because there's like only 2 categories here, so you can just use this. And this should be 0.9854. So for this document, this is going to be an informatics document. Now, if I wanted to use Laplacian smoothing, basically I would have, like, instead of using these values here, you would have added the features number. So let me just show you a very quick example here. So let's say I'm here, right? So let's say instead of this thing, you're going to do like 1 by 3. So 1 by 3. Now you're going to, if the Laplacian smoothing gave you a value k equals 1, now 1 plus 1, this k, so 1 plus k would be 1 plus 1, and on the bottom 3 plus 2. So I chose 2 because there's only like yes and no. Okay, so if there was like yes, no, maybe, it would have been then 3 plus 3, but since there's only 2 variables available for this feature, so it's going to be 3 plus 2. So same thing for the other one. So 1 by 3 plus 1, then for this one as well, so 3 plus 2, then times 2 by 3, 2 plus 1, 3 plus 2, times 1 plus 1 divided by 3 plus 2, times 3 plus 1 divided by 5 plus 2. Okay, so this is basically how you do Laplacian smoothing.